Okay, I think we are pretty good. We are all set, so we can now formally start the session. Which is what please have a seat, and I will sit here. And okay, so I think this last session, last technical-ish session, is the one on panel discussion on shape modeling in academia and industry. So I'm gonna maybe request who just want to say it. Yes, we can start with our panelists, but I'm sorry, I was missing a few things before. So have we done a round of introductions of all our panelists?
Yeah, so we can
Okay.
do that. So,
Okay.
so maybe we can do a quick round of introduction. So, Geetika, I don't know. So, physical participants have listened to you, but online participants said that there was a lot of follow-up. Do you mind a short introduction quickly so that they also get to know you? Yes.
So, very good morning to the virtual audience as well as the physical audience. I'm Geetika Sharma. I've been working, in the 3D graphics area for more than 15 years now. My career started with a PhD in image-based rendering from IIT Delhi. Post that, I worked mainly at TCS Research for close to 10 years, heading the virtual reality group there. Then I co-founded a startup called Bizarra, where we were working on AR, VR, and 3D printing for heritage applications. And currently, I'm freelancing as an XR consultant and researcher.
All right. Thanks. Thanks, Geetika. And should we do? I mean, the participants already know our earlier speakers, so that doesn't need any introduction. But I hope we have most of our participants online. So the way we want to conduct this session is, this session is designed for the participants to give an understanding of how to proceed from here. I believe that you had wonderful 2 weeks where you got some idea of what is shape modeling and some basics, and including some advanced stuff toward the end, perhaps. So the idea is, how do you take this forward? Where do you go from here? And that's why we have this panel discussion today, where our experts are going to give you some guidance on what can be done from here. Some of you are in your bachelor's program, and some of you are in your master's or maybe PhD. So what are your career options after this? So maybe if I want to request our speakers today to maybe talk about 3-4 minutes on their thoughts on this field of shape modeling and career options going forward here. Now, many of us are from academia, but some of us have industry background, including me. I also have some industry background, but then definitely we have 3 people here who have some industry exposure. So I would request all of us, including our academic speakers and also industry speakers, to spare 3-4 minutes and speak about what they think would be what their thoughts on career options within shape modeling. So maybe we can start with Geetika, you first. All right. Okay.
Yeah, so when we talk about shape modeling and careers in shape modeling, there's actually, this is, I think, the best time to be in this area, because there is a lot of growth that has happened, and there is a huge potential and demand for people in this field. So if I talk about specific applications or industries, of course, gaming, film production, animation, this has been there for a long time, and it's still, it's just growing. If you think of any industry that involves design, prototyping, or simulation, that's another area. So, like manufacturing, industrial machinery, there's a lot of prototyping happening in, say, car manufacturing, and other possibilities are like one of the projects that I'm working on currently, which is virtual garments for the fashion industry. So across industries, people are realizing that a lot of prototyping can be done digitally before the actual product is manufactured, and even samples are created. So, and if you think about, these industries, the requirements change, right? So if I'm talking about gaming or film production, I don't necessarily need to have very accurate garments for the characters, and my animation has to just be believable. It has to look visually plausible. But when I'm talking about an industry like garments, where I want to manufacture actual clothes that people are going to end up wearing, then I need to be accurate, with my designs. Garments start off with actually pattern making when once you get into the manufacturing process. And these are 2D patterns, right? But out of those, you need to construct a physical 3D, outfit which people are going to wear. So if my patterns are not accurate, um, there's going to be issues later on. So those are some of the more challenging areas, but there's a lot of scope, and it's not just from a design perspective, even from engineering. There's a lot of things to be done. So a lot of scope for people like you who have a good understanding of 3D graphics, the whole graphics pipeline, how it works, plus with experience with different kinds of tools and development environments like Unity and Unreal.
Wonderful. Thanks, Gitika. Uh, okay, maybe I can check with our online speakers and request them to, give their thoughts on this. So I can see Siddharth. Do you want to speak on 3-4 minutes? He's speaking, but I think. Siddharth, just a sec. We have to get you audible here in just a second. Okay. We'll just route your audio to speakers here. This was expected, I believe. So, can you try now, please, Siddharth? Siddharth, would you want to try now speaking?
How about now? Can you hear me?
Perfect. Thanks. Please go ahead.
Okay, I hope I'm not going to cause too much echo on your side.
Not at all, not at all.
Okay, now I can hear you echoing, but I assume that once I start talking, that reduce. Okay. All right. Thanks again for organizing this panel discussion. It's great to see everyone here. I'm hoping to hear also some interesting contributions and feedback and comments today. The introduction mentioned that we have people from academia and people from industry. I happen to be in both camps because I'm a researcher at Adobe and I am also in very longly in a position as assistant professor of computer science at Alibaba. So I've sort of been on both sides of the fence and I still sort of am on both sides of the fence. Though I don't do very much active work on the academic side anymore. But the work I do in industry is still academic research. I'm largely concerned with the sort of work that goes into publishing research papers, and the time I spent teaching has more or less transferred the time I spend working with product groups on how to get this research into actual products. So the issue of how geometric modeling and shape modeling can relate to real world applications, what the industry take-up is like, what the opportunities there are. This is a very broad discussion. And this has become a broader and broader discussion in the recent past because it's turned out that the tools we develop for three-dimensional and two-dimensional shape modeling feed into a variety of increasingly popular direction. One which Geetika has already talked about are things like virtual 3D prototyping for clothing or machinery or various other things, household products. Most of these are designed by a computer these days and using some sort of a CAD program or a 3D modeling program, and that it is eventually leads to application. There are strong ties with simulation because there's this feedback loop between designing something which uses the geometric tools that we've been discussing in this summer school, and the feedback loop is with the simulation cycle, which is often also done virtually, and then based on the results of the simulation you update your design. There is research on making this feedback loop automatic or semi-automatic so that the design can be optimized automatically. And there's a lot of very interesting research going on, and there's a lot of interesting industry pickup on these sorts of things. So things that were previously the domain of very, very expensive, high resource computing facilities like wind tunnel simulations and so on are becoming more and more accessible, and there's a lot of opportunities for computing in space. But another direction in which I think geometric modeling has had a lot of real world impact in the recent past is because of the dramatic popularity, the dramatic uptake and success of computer vision techniques. Now, computer vision doesn't immediately seem, the things we normally think of as computer vision, when you look at a picture and tell me what's going on in this picture, describe it in a sentence. These images are mostly raster images. It's not obvious what the geometric modeling or shape modeling aspects of this are. So I think it comes in two ways. One, the real world is 3D. There are various ways of getting information about the 3D structure of the real world. This is the province of what's called 3D vision, and this can be done through stereoscopic vision, massive clouds of images, through actual 3D acquisition like LiDAR and range sensing and so on. And this sort of information is processed by the geometric, algorithmic and mathematical tools that you've been studying in this summer school. And this is really, really current, and there is a huge amount of interest in this for things like, I did just jump on the buzzword, but things like the self-driving cars or things like that. Whether self-driving cars are the best place for us to invest humanity's net energy is I think a point for discussion, but that aside, there are all sorts of opportunities here which use these tools. And the point I tried to make in my recent talk in this summer school is that techniques don't naturally transfer from standard 2D vision to 3D vision. Because 3D objects have particular types of mathematical structures, we need to develop the mathematical tools to allow things like machine learning to work on these structures, or optimization to work on these structures. And so, again, these formalisms that you've seen over the last several days have a direct impact on understanding and developing algorithms for this type of reasoning and this type of data. And of course, these are often problems of reconstruction or classification or perception, but there is also related work on synthesis, on constructing three-dimensional objects for purposes of prototyping, for purposes of various other types of applications to games, virtual reality, immersive media. So that's again an area that is very current right now. Immersive media is a catch-all term for virtual reality, augmented reality, and mixed reality. So I think there is a lot of application of these tools to these areas. I've mostly spoken about these 3D applications of shape modeling. I also want to make the point that there are many 2D applications of shape modeling, and it's sort of nice to think about where these applications could be. So, for example, I work at Adobe. We have this product called Illustrator, which some of you may have used. It's a product for designing illustrations using vector graphics as opposed to raster graphics, which means you use equations to represent the shapes that go into creating some illustration rather than grids of pixels. And a lot of the mathematical machinery underlies such a vector graphics design tool, and these are very, very widely used, are very, very much the 2D analogs of the 3D geometric modeling algorithms that you've seen. Of course, Illustrator now has an additional 3D push as well. You can design 3D directly with Illustrator. I don't want to make this completely specific, so you can extend this argument to any other vector graphics tool out there, 2D vector graphics tool out there, like Inkscape or various others. For the web, there are all sorts of easy content creation tools which involve putting templates together, changing them parametrically, and so on. And again, the algorithms that are used there are core shape modeling and shape analysis algorithms of the sort that you've seen in the summer school. So I'll stop there, and I'm happy to discuss more about any of these things.
Excellent. Thanks, Siddharth. That was really comprehensive and covered almost all areas. Maybe I can request Ramanathan. Are you there? Yes.
Anyway, I don't have my camera, so you will be able to see me as such. That's okay. So, am I audible? Just can you just
Yes, Ramanathan, please go ahead.
So, in any case, I don't have my camera. So, anyway, I think hopefully all the participants enjoyed the entire summer school, covering wide spectrum of people from different backgrounds. I was there, Siddharth, from computer vision guy, but from the graphic picture of us, deep learning. Also, we brought on then Vijay was there, I think, and of course, this Kaushik. So, we had to cover a wide spectrum. So, maybe I'll just give some experiences with this project that I have worked on with some companies, and mostly it's a 3D side and some on algorithm. So it looks like many of the things that what we see as that point out something on 2D, and some may not have any looks like may not have any context at all. It's not entirely true. Like there are lots of industries, for example, we did recently work with Siemens. Siemens PLM is a big thing for them. So they are trying to bring in some new ideas from the sketch-based, starting and then how they decipher 3D models. These are basically geometric modeling problems. Okay, so how do you convert a 3D model into 2D image, a 3D sketch? But it is more from the engineering perspective. Not from what that talked about computer vision. Typically, they do that, but this is from the engineering context. Like for example, if you have a connecting rod or a crankshaft, and somebody draws a connecting rod, okay, and then how will you generate a 3D model out of it, or at least a sketch-based retrieval, which is also popular in graphics. It's also a popular problem in engineering. Okay, so it's typically like a Google which has a text-based retrieval. So this is the engineering context. So a lot of industries are looking at this problem, and then there's a whole pipeline integration. So this is not just you do something and go off, but it's something like a design and analysis. So once you design this, you pick a 3D model, then you go back to finite element analysis, and then you actually go to NLP problem to decipher some right information on the analysis, and then you go back and redesign. So this is like a complete loop. The big thing currently coming up. I think Siemens is doing something on that. We did this entire pipeline, which is of us got together and did. So this is completely on shape modeling, geometric modeling. It involves many techniques. Some on we use deep learning, some probably not without deep learning, more on optimization. But either way, this will come around and around all these words. I think everybody will be using nowadays with optimization, learning, machine learning. So most of them have come into that domain, including engineering. So because that analysis can be really difficult and time consuming. For example, an FEM analysis could be really very expensive. So can you just decipher, can you do something without using FEM? Of course, you need some data if you are using deep learning. So you can generate some data, and assuming you can generate, then you can do. Okay, So then there are other problems like crash optimization, or if you go and crash a car, what are these effects? So there the problem is that it's not a big data, it's a small data. You can understand you can't keep crashing cars to get data. So that's not feasible even for big companies. So there you get a small data. Okay. Now how do you get study this from this small data? How do you actually decipher information? There are also a lot of automotive industries are very keen to look at it. Okay, not from they may not be machine learning or even deep learning, which are all typically data intensive, but this is a small data problem as opposed to a big data problem. So a lot of automotive guys are keen onto this study. And then there are other things like if you understand from design all the way up to the full pipeline, we do the design and manufacturing. There are a lot of people do what are called as dimensional detection. Like you may have heard of that term in the context of machine learning, PCA, but here it is in the context of 3D models. Okay, for example, if we have a model with heavy features like a lot of small holes and slots and so on, people want to install as a feature-based problem. We want to remove such probably not very relevant in terms of the bigger picture of the analysis. So this is called as a dimensional detection problem. And here again, a lot of industries, automotive industries in particular, are very keen to work on this problem. Okay, this is one thing. And if you want to look at somebody from algorithms, okay, like a shortest path problem, or what we talked about, arbitrary problem in the class. So we did this with a simple polygon and basic for like 4 of n by 3, and it looks like it is completely out of place. Okay, so where this could be used, okay, that question may come. But actually, it's all very relevant because we actually did one with Caterpillar, where they want to study this problem on reducing the number of lines on the excavator. These are the red movers. So they are apparently big, expensive lines. So if you can reposition them and reduce from 4 to 3, that's a big task for them. We are making it much lesser in terms of the resources, but in the intensity pattern and this is very similar to our gallery problem that we discussed, except that the light and other things come into picture and there is an intensity pattern. So you can see that across the different industries there are lots of job opportunities, but as Siddharth made a pointed out, a lot of guys are using deep learning at this point of time, even in the industries. I don't know about Adobe. Adobe also, I guess, in sketch we do that. But even in the mechanical industry, I know one of the students recently joined in Caterpillar. He was particularly hired for as a senior data scientist. So Caterpillar has a lot of data that are more legacy data, which is probably 60, 70 years back data. But how do you convert them into a digital form and then make use of typical data analysis? It may not be deep learning, but something based on data. So a lot of automotive companies, particularly mechanical related companies, we did one problem for Stons, who has a search engine on 3D models. So we actually did some segmentation problem for them so that if mechanical objects, if you just segment into different components, so which one can be picked for some other model. So it's like a partial search problem on the mechanical side. So all the problems also related in computer vision and other aspects of geometry, but it's also very relevant engineering, which I think Siddharth also the ABC data set, which is come by these other guys, but they don't have classification information. This I think discussed. So a lot of scope for research, a lot of scope for industry guys. So even a lot of industry guys want to do more research on this and improve their existing product life cycle, the entire software pipeline that we already have. They also want to try out different things. Particularly, I think though we may not have discussed all, I think it is probably inevitable that the data science comes into the picture at this point of time. So what we discussed more on geometry and algorithms, but I also tell the participants that they may update themselves, in their knowledge on learning something on machine learning and feedback. A lot of industries are looking at that, and I'm sure from the graphics, even Siemens, Samsung R&D is also a lot into graphics, again geometry modeling. You might want to get in that. So there are some of the students who is leading the team. So So we have a lot of industries in India, particularly not just abroad. They are looking for people who are developing on algorithms, programming, who have background in geometric modeling, and of course there are lots of aerospace industries. If you know Bezier, B-spline, okay, they will immediately hire you. Maybe even if you are uttering the word of B-spline, you may get a job in Airbus because there's not many people even know of the idea of the B-spline. Because aerospace industries bread and butter job is B-spline, and automotive also the Bezier surface. Okay, we call it as class A and class B surfaces and so on. So it is not that people in geometric modeling will be left jobless, but you have to figure out who are the right industries that you can go to. So with that, I think I have given a brief idea of what various industries are looking for. Though possibly I am not the right guy to talk about it sitting in an academic institution. Other guys like Siddharth probably better fit to talk about industry, but we have collaborated with the different industries. So based on my experience, I think still people are looking for guys who have done a lot of geometry, shape, but I think added to that you might have to bring in data science, which is becoming inevitable. So with that, I think I'll just conclude, and if you have any questions, I'll be keen to answer.
Thanks, Ramanathan. So definitely, academic viewpoint is also important because either we have worked in academia at one point of time, or our students would get jobs in these industry areas, right? So excellent. Thanks, Ramanathan, a lot. Okay, so we have two more here. So Aditya, would you want to give your views quickly?
Properly, or just think a lot of echo and things coming in.
I think it's mainly from our side here. Aditya, are you there?
Yes.
Okay, so yes.
Okay. So thanks once again. Just for watching that. See you for having this summer school. So as far as industry and application is concerned, I think I have a time slot over there. Still, give my opinions in class. So accordingly, I think shape modeling is perhaps where we assisting in computer vision over about 3 decades ago. And I hope after going through all the content of this summer school, participants agree with me that it's basically an interdisciplinary area that of shape modeling and cannot do or survive without contributions from several areas, computer vision, graphics, image processing, geometric modeling, computer science algorithms, and of course, core areas in mathematics, for example, optimization. And the good thing about this is that you not sort of know all of these areas, you may not be expert at all of this, but then you can sort of contribute according to your expertise or your interest. And that is perfectly all right. Especially these days, a lot of 3D data is now being generated and made available for everyone to analyze and process. I think the interest, the contributions are just going to grow in this area. And as several speakers have already mentioned, there are several applications ranging from 3D medical imaging, immersive experiences for consumers. For example, my PhD student last year was trying to model 3D hair, possibly for products, trying to give how their hair might look if they use a particular hairstyle, etc. So something that we think is crazy, but yeah, immersive experiences are just going to grow. So yeah, I encourage all participants to explore more, find out more about this area. Feel free to contact me or any of the speakers. Will be available. So that's about it. Thanks.
All right. Thanks, Aditya. Okay, great. So Venkatesh, I can see you are also joined in here. Would you want to share your views?
Can you hear me?
Yes, Venkatesh.
Yes.
Yes.
Okay. Yeah. Yeah. Thank you. Thank you for giving an opportunity to me to say a few things at this panel discussion. Now, I come from the organization side. I represent BCM India, and this is the second time that we are organizing the shape modeling workshop. Some of our concern in the steering committee has been somehow this is a very niche area, and that's one of the reasons that we are not getting a large number of applicants. Um, Partly the problem lies that we are not able to reach right kind of people who might be interested in this area. Now, I'm an old hat. I have seen, how computer graphics discipline has grown in the last 40 plus years. I mean, earlier things were very defined. I mean, graphics was synthesis problem and vision was analysis problem. But somewhere in 90s, things changed with the Stanford project on scanning, the so-called Michelangelo project. And now you can distinguish between these disciplines, and you see a lot of and the boundary has literally disappeared. But at the same time, I see Viveka and others also talked about engineering and some of the entertainment or fashion design application, but there's a whole area in medical field which is also do some kind of a prototyping. I mean, I remember some years ago a group of orthodontics were interested in knowing when the treatments are being done on a patient. I mean, these treatments are for long duration, 2 years, 3 years, and that changes their shape, and those changes are so minute that often the patients or the doctors are able to find it difficult to see that change with the naked eye, right? So, is it possible for us to do some kind of a heat map to show the changes in the face at what portion it got changed, right? I mean, so, and of course the prediction, right? How would I look after the treatment? Because that's a really it's a $1 million question, because the patients invest time, energy, money in the treatment. At the end, if he's not happy with the result, then suddenly he feels that all that money spent on the face aesthetic is lost. Right? So I feel that the biological shape modeling, the organic shape modeling are also our application area. I don't see much happening in India. Maybe I'm not aware, but certainly we lack the data sets. I mean, we don't have mechanism to capture these data sets so that somebody can try out their algorithms, to see how effective they are on the clean data sets. One challenge that I see is, as the field has grown, the mathematics stack required to understand the recent development is also growing. I mean, I think particularly since our target audience is undergraduate and BTech students, I have a feeling that many of them are not exposed to this in their regular courses. The linear algebra that gets taught in typical engineering program is often taught by mathematics faculty, and you must have seen that the way the linear algebra is perceived by different communities, right, from physics to electrical engineers, computer science people, has been the treatment needs to be a little different. Okay, and that's why we often see book linear algebra for computer science people, linear algebra for electrical engineers, and so on. right? So I think many students, while doing their undergraduate program, do not find motivated to study these subjects deeper. And often I have argued that it might be better if some of the engineering faculty, computer science faculty, or mechanical engineering faculty teach these fundamental courses, which might give a better idea to the student, and they may feel motivated to study these subjects deeply. I also see now, apart from the standard linear algebra, optimization, probability, statistics, but now I'm seeing also differential equations and PDEs and all that coming in. So I think it's little intimidating for somebody who's starting fresh research in this area. Maybe a couple of years will just go in getting some hand of the wide subject areas that gets covered in the so-called, as Aditya mentioned, it's an interdisciplinary field. But I see that it's our efforts should be to sustain these kind of summer winter schools in order to keep the interest going. I mean, it will take some time for us to it would have been great if we could have put together a project in the DST or some kind of a government funding agencies where some of the groups working in this area to collaborate and submit a project. Okay, I mean, some of you will be aware of that earlier project which was done by the Vision Group. I think it was called Heritage Project or something like that. I think that gave a lot of opportunity for research, individual groups, and also opportunities to collaborate. I think something like this we should think seriously as a group, and we hope that ACM will continue funding these kind of summer schools in the future. Thank you all. This is the first time I should mention that we were trying out the hybrid mode, and I saw how Ojesh and Kaushik were struggling. We noticed that it's easy to organize something in online or offline, but hybrid mode is always a challenge. And unless we have a very stable setup at the venue, it becomes very, very challenging. But I'm very happy that in spite of some of the teething problems, overall the workshop went off well, and my congratulations to the coordinators, Kaushik and Moses. Thank you.
Thank you so much, Venkatesh. Thanks for the nice words. So, thank you all for speaking. Maybe, Kaushik, do you want to speak?
No, actually, I'm going to say, Ojeswa, you should say, given that you have a industry plus academia background and you have spent some time again in the industry, maybe I think you have a perspective that you could share that would be
so, yes, I can.
complementary to what has been spoken.
Right. I think a lot of what I have experienced has already been covered by Gitika, and then also Siddharth has covered quite a lot. I can tell you, I have been with 2 to 3 corporate research offices earlier. I have been with Fluent, which is now with ANSYS, which is in Pune. So ANSYS, Fluent at that point of time was mostly working with computational fluid dynamics simulations. So I can tell you that scientific simulations need geometry, and it's a very specialized geometry. I think Ramanathan mentioned about FEM meshes. So you need, be it 2D or 3D, you need to create meshes of geometry. So you have to have understanding of how do you represent shape. We discussed about some data structures, we discussed about shape representations. All of that knowledge that you have gathered in this summer school will in some way or the other will be useful if you ever land into a job in corporate development or research. For example, as I told you, I worked with the simulation company, and then I also worked with Samsung. I believe we have heard Samsung already a few times in this panel discussion. Now, Samsung Bangalore, where I was, has an R&D unit, and we work on very many different projects, and those are research projects. And I can still remember the project I worked for long was on 2D animation. We were trying to design a tool where you could sketch characters, and then those characters, you would be able to animate them on a mobile phone. Okay. So Samsung at that point of time had come up with a stylus in their mobile phones. I think those phones were called Galaxy Note, if I'm not wrong. So they wanted to make a good use case for that pen. I think it was called S Pen at that point of time. So they said, okay, could you design something that would animate on and use this S Pen exclusively? I said, yes, we'll try that. So we went on to design this animation software. It was more on a research mode, and I think it never got into, it was never released, but it was a very interesting experience. And all of our knowledge of shape modeling and animation, I think Aditya covered some principles of animations here. All of them were utilized. Right? Then I had also had opportunity to work with Nokia Research recently, and they are looking at what is known as volumetric videos. So think of volumetric videos as four-dimensional videos. So that, of course, the capturing part is a bit tedious because you need very many cameras, and then from those cameras you essentially capture what you may call a light field. So that when you play back that video, it's a 4D video. When you play back, you can place your camera anywhere in the scene, and then basically play it back from an alternate point of view. And that gives a different perspective. Imagine a cricket match being played, and then you have a volumetric video. You could see what's happening, and you could even pause in between, rotate the camera around. So that's about volumetric video. Like they say, volumetric video is the next stage of videos that we watch today. So I remember Siddhartha talked about NERFs, NERFs. Some of you who were here would recall that. I think NERFs find a great value in volumetric videos, in my opinion. And this is still an evolving area. So there is a rat race. There are a lot of companies that are working toward making volumetric videos a standard. Some of you might come from ECE background. I don't know anybody from ECE background here. You would or maybe 2D videos or just videos that we watch today. The formats are standardized, right? So there is a race among companies to standardize volumetric videos because it's just in its infancy, right? And so encoding and decoding of volumetric videos, and so there are a bunch of very, very interesting problems in and around that. So how do you reconstruct efficiently and accurately a deformable or a kinetic scene, right? That's one problem. How do you efficiently capture it? How do you reconstruct it? How do you encode it? How do you transfer it on let's say, a 5G network? So these companies that I'm talking about, Sony Research, Nokia Research, they're all into encoding, decoding, not into the reconstruction side. The reconstruction is primarily with academia and maybe with some startup companies today. So all in all, what I want to say is that there are, and then of course, we should not forget about the gaming industry. Right? The gaming industry uses the geometry is bread and butter for gaming industry. Then there is VFX industry. So you need geometry for that. Sometimes you can go away with less detailed geometry, but many times if you want a stunning experience, you need detailed geometry. That's a must. And coupled with the rendering algorithms that we have today, you get what you see in Pixar movies. This is truly amazing. So all in all, what I want to say is that all of these companies that work on visual computing, scientific applications require geometry. And a solid understanding of shape modeling will take you to a new level. If you approach these companies and you say that yes, you have a good understanding of shape modeling, they'll take you. Because take my word, there are not too many people who know about this. So this is your chance to probably learn a little bit more, follow it up from where we are living today. And I think these companies give you immense opportunities to grow within this domain of visual computing, geometry, and shape modeling. All right, so I think I'll close with that, and back to question.
All right, thanks everyone for sharing your varied viewpoints, academia and industry, and blend of academia and industry. So in the interest of time, I'm gonna we will have some open discussion questions from the participants or the audience members here and online. But maybe one or two quick questions, especially for Geetika and Siddharth. So we were talking about all these industry applications, role of shape modeling in industry, but maybe a more banal question, something a student would be expecting to hear or learn about is what would be a typical entry level role in a shape modeling position in the industry, and then what would it evolve into as you go into mid level, and perhaps we have got some idea of what top level functions folks here are doing, but entry and mid level, if you could come in, that'd be great. I'm going to ask Geetika first, please.
Yeah, so a typical, entry level position would be either an ML engineer or 3D graphics engineer, and both of these require very strong 3D graphics concepts and knowledge. Another role that I find very interesting is that of a technical artist, and that sort of role you see in gaming companies where you need real time rendering. So your models and things have to be highly optimized. And when 3D artists create those modeling models in these companies, it's still the models are pretty much done by hand by 3D artists. But generally they will not be optimized for real-time rendering. So the role of a technical artist is to be the bridge between the 3D artist and the engineering team that's putting the game together, so that the end result comes out looking really good. And a technical artist is someone who starts off as an engineer and learns the other side of it. Usually, there are very few 3D artists who can pick up the engineering aspects that are required in this role. So that's an interesting position. And then of course from there you move up the hierarchy. You get into senior positions, maybe even technical director for the game or for whatever application that the industry is working on. I think
Thanks, Geetika.
Okay, thanks, Geetika. And maybe the same question to Siddharth online as well. What are some entry level roles and mid level roles in your perspective?
Relevant and informative. I think I can sort of expand that a little bit to say that there are, this also goes back to what many panelists have already said, which is that there are many roles in many industries that require geometric algorithms. And these relate to engineering industries, Rama's brought up the issue of Boeing and working with spine services. For example, as a particular case, or the medical industry, which is useful, which Venkatesh brought up. And I really should have mentioned that because so much work in medical vision in things like protein folding or structural analysis, drug design, essentially use things like geometric algorithms. So there are, I think, also a variety of roles in such companies who are looking for people who will apply these geometric, broad sense algorithms to very specific tasks. And I think it's difficult to comment, to make general comments about these because these are specific roles, but I think these also exist. I also want to add, as I said in my opening talks, that there are similarly many roles that require knowledge or expertise in two-dimensional geometric modeling. I'm not glad I advised at Bombay. I recently got hired at Adobe for working on vector graphics problems, and I mean, he has experience in 2D graphics, 3D graphics, and elements of interactive design and ACI, and all of that turned out to be useful for the role in which he was hired. He's not working with me, he's working with a completely different group. That turned out to be immediately relevant. So there are many cases of 2D applications of geometric modeling which are important in things like illustration design. Again, if you have expertise in these areas, you will be hired as a tool, as a technical artist in that sense, or you might be called research engineer of some fashion or research associates. In these titles vary across companies. But basically, you are a tool builder who's helping the people who actually make the content, whether they are within the company as in animation or game, movie or special effects companies, or outside the company as in tool building companies like Adobe or Autodesk or Unity, such companies. I think that's something to keep in mind. And also the other thing, the last thing I want to say was, in addition to these tool building companies, there's also web design and many aspects of modern web design and interactive interfaces again rely on low-level geometry processing to pull off many of these fancy interfaces. Again, that's
Okay, thanks, Siddharth. Maybe one last question from us folks, and then we'll go to the audience and ask the questions. And this is also a very hands-on question, maybe to all folks. There is a small worry that would Python knowledge alone be sufficient for doing graphics, processing, shape modeling in the industry or even in academia? Or does one have to necessarily learn C++ or something similar to get going here? Please give us your thoughts maybe in a minute or so. Each panelist will be great. Maybe I'm going to ask Ojaswa first and then Geetika, then we'll go to the online ones. Yeah, Ojaswa please.
So in my experience, and I'll not talk about academic research because I personally use C++, MATLAB, and also Python in my research. But let me tell you what industry uses. Okay, and I've worked with 3 industries, and it has been C++. Ansys Fluent being a CFD company, all of their code base is in C. So they exclusively use C. They used a scripting language called Scheme. Then Samsung, again, we used Samsung we used C++ and Java. And Java because that was an Android application. And then different groups use different. See, it's more of in a product-based company like Samsung, it could be very varied. They may use Python as well. But for example, another group that was working on codecs, 2D video codecs, they were using GPU computing as well. But that is again in C++. And then of course, Nokia again C. So my experience has been C++ is widely used in graphics, geometry related tasks. But I can see that the world is moving toward Python, so maybe I'll move. I'll request Geetika to comment on that.
Yeah, I would say, for more engineering sort of applications, even for games, C++ is the language that is used. And Python, because of all the ML work happening in Python, companies are now forced to sort of get into that. But they would prefer C++. Some of these engines like Unity uses C#. A lot of metaverse platforms have their own editors in which you have to work. So it may be another scripting language like Lua or something else which they've made another language that they've developed specifically for their application. But at the core, everything is still happening in C++. When I was at Samsung in Noida, we were actually working in OpenGL, so we were doing hardcore OpenGL applications. So I think knowing these things, because scripting languages you can always pick up, those are really easy to learn. So if you have a solid base in C and C++, you're set. So
I'm going to invite the online speakers to, the panel members to please comment. But I'm just going to make one short remark that this is antithetical, or maybe Venkatesh can comment at the end, to what is happening in academia, where Python is largely the base language which is being taught, and data structures are being taught with Python and so on. So I'll leave it at that remark and invite the online panelists to please share their comments on this.